I wanted to give a short update on my experiments with NLP and the ARC challenge. My work this week was focused on comparing the results of different NLP models and different data formats. I also wrote a Jupyter notebook for visualizing the results of multiple models simultaneously. On the screen, you'll see the last frame from the ARC challenge. The first item is the input item, and the second item is the output item. The third item and fourth items are the GPT-3 model outputs, and the first one is the Curie model, and the second one is the Davinci model. The Davinci model is the full 175 billion parameter model, and the Curie is, I think, about 10 times smaller than that. And so if you would take a look at those results and compared to the actual correct answer, you'll see that Curie and Davinci are generally somewhat in the right neighborhood in terms of like having the right colors and maybe having some of the right shapes. But they just generally don't quite get there. Now the fourth one was a fine-tuned BART model, and if you don't know, the BART model is it's known as a denoising autoencoder. And so I fine-tuned that on the Hugging Face website. Now, in terms of what I've tried to do with the data, is there's different ways that I've tried to format the data for the fine-tuning, and we'll show that to you here. So one way is to do it using numbers and to have spaces between the numbers. Another is to use numbers and have no spaces. Another is to use letters and have spaces between the letters. And the fourth way is to have letters but no spaces between the letters. So for the BART model, what I used was the letters with no spaces between the letters. And you can see it does have some similarity to the output on some of the items, which is not terrible given that it is a much smaller model. Now the last 4 outputs are from a single model. And what I did with that model, it was a BART model also, is I trained it on all 4 of the data types. And so the question I wanted to answer was, which one is better, the letters, numbers, letters with spaces, or numbers with spaces? And so I trained it on all of that data, and then I ran evaluation data set and had the model produce outputs for each one of those different data types. And I think the results of that show generally that letters without spaces are better, although it could be somewhat debatable at times with the numbers without spaces being better than letters. So that question seems to be unanswered, but what is answered is that it's better to not have spaces than to have spaces. So if you would take a look at those last 4 items, the last 2 are the ones with spaces, and so the first one in that group is letters without spaces, and the second one is numbers without spaces. And you can see that those two seem to do much better than when spaces are included, generally speaking. My idea for why that would be is that, at least on a conceptual level in the data, it would introduce a little bit higher level of abstraction by not having spaces, and that has to do with the tokenization process, where it would include multiple letters, whereas if you use a space, each individual cell would have one token. Now there's a kind of an interesting challenge with this, and it's something that I have labeled semantic baggage. And so what I mean by that is that certain sequences of letters or numbers tend to be tokenized together. I'm not certain how BART does it, but at least on or with the GPT tokenizer, it might tokenize something like CDC or CIA or other kinds of things that might resemble a word or an acronym or things like that. And the same kind of thing with numbers. So you can imagine like the number 300 might be associated like with the movie 300. And so that's kind of one way that I'm thinking about it, and I haven't explored the implications of that in great detail, but I think it's at least something to think about when it comes to these language models. And that brings you up to date on the research that I've done. What I will be doing next is a series of experiments to try to see to what extent can language models do feature detection on the grid to be able to detect features of the content, and to be able to detect also like the transformations. And so along with that would be the ability to produce a grid that has certain features and to perform certain transformations. And I will also be experimenting with doing different fine tunings. And what I want to be able to do next is to find kind of the ideal test model that I can fine tune, like in Google Colab, or in a way that is more affordable and that I have more control over the hyper parameters. And I'm currently doing that now with a T5 model, and we'll be experimenting with the hyper parameters on that to see how far I can take it with the transformers. And that's it for now.